Hi, everyone. Good morning. Happy Wednesday. All right, happy Wednesday. Today is August 5th. Dates are hard. Here's your do now for today. What is your favorite flavor of ice cream? That's your first question. Write down your answer in the chat for that one. And then your second question is math related. Describe the transformation of the parent function f of x equals absolute value of x if g of x is equal to absolute value of x plus 9 minus 5. And that's, I'm going to ask you to share that out loud. So don't put that one in the chat. The first one in the chat. Ooh, we got some salt.
Hello, Miss Bagwat.
Yes.
Hello, you can hear me?
Yeah, who am I talking to?
Then I'm doing this through my phone, so I don't know if it's like access my camera because I'm at work right now.
Okay. I think I see your video so far right there.
Got niggas here.
You said what?
I could see your video.
Oh, you can? Okay, good.
All right, we got salted caramel ice cream yesterday. It was bomb. We got strawberry. We got mint chocolate chip. All of them. I feel that, Noah. Cookies and cream, vanilla bean. Oh my gosh, fancy, Gavin. All right, we got chocolate chip cookie dough. I had that ice cream yesterday too. I had a lot of ice cream yesterday. Moose tracks. Good. Ben & Jerry's brownie batter, delicious. A classic chocolate chip, love that. Keep answering your favorite flavor of ice cream in the chat, and then I'll call on someone for number 2 in about a minute. Ooh, we got a new one. Why does it do this to me? Okay, there we go. Strawberry classic. Ooh, we got a couple strawberries. $30 more seconds. 30 more seconds to get your answers in the chat. Cool. All right. So I got all your answers in the chat. So let's go on to number 2. Describe the transformation of the parent function f of x is equal to absolute value of x if g of x is equal to x plus 9 minus 5. Go ahead and describe the transformation for me, Anel.
It goes to the left 9 times, and it goes down 5.
Beautiful. Yep. Left 9, down 5. Perfect. Left 9, down 5. Any questions about how Anel got that answer? No, we're good. Awesome. Okay, great. Let's go ahead and move on to good things. So today our good things will come from Elise, Fresh Salam, and Gavin. Elise, Fresh Salam, and Gavin. I'll start with my good thing. My good thing was I played tennis after school yesterday, and the weather was really nice. And I hadn't played in a while, and it was really fun. So that was my good thing. Elise, what's your good thing?
Yesterday I drove, and then today I work.
Cool. Where do you work again?
Papa John's.
Awesome. Do they give you free pizza?
No.
Oh, drat. If only. Thanks for sharing, Elise. Freslam, you're up next. What's your good thing?
I played basketball yesterday.
You played basketball yesterday. Very cool. Thanks for sharing. And then Gavin, what's your good thing?
Yesterday I saw my great grandma.
Oh, awesome. Very cool. Thanks for sharing. All right, so let's go ahead and get started with our agenda for today. So we're going to be doing notes, and then hopefully we'll have time for a Kahoot. If not, we'll push it back till tomorrow. We'll see how far we get to with our notes today. Before we do the notes, though, I want to give you all time to answer any questions from the homework last night. Remember, that's going to be due tonight at 11:59 p.m. So I'll give you all a few minutes if you have any questions that I can answer about the homework. All right, no questions? Last call for questions on the homework. Okay, cool. Let's go ahead and get started with our notes then. So you should have been able to find today's notes on Canvas. Remember, notes are always posted by 8 p.m. the previous night. You're welcome to print them out. You can write them out by hand. For today, it's probably more helpful if you print them out because there's a lot of graphs on it, but do what you got to do. Whatever makes sense to you is fine with me. Let's go ahead and get started with our notes for today. So here we go. All right, so yesterday we talked about absolute value translation. So a translation is when you move a graph left, right, up, down. So all you're doing is changing the position of the graph. Today we're going to be talking about transformations. And when you talk about a transformation, not only are you shifting it up, down, left, right, you are also potentially changing the orientation. So again, orientation means which direction it's facing, whether it's facing up, down, right, or left. You're changing the size. So that's where the stretches and shrinks come in. And you could also, again, change the position. So it says fill in the blank, but I filled them in for you. The first type of transformation we'll be talking about today is a reflection. So a reflection is just a fancy math word of saying flip. So a reflection over the x-axis will flip your parent function over the x-axis. And just as a reminder, when we talk about absolute value, the parent function is that V-shaped graph that has a vertex at 0, 0. So when you're reflecting it, you're taking it and you're flipping it over. So now it's an upside down V. A vertical stretch will stretch the graph vertically away from the x-axis. So what that means is if I were to take the ends of my graph and lift them away from the x-axis, that would be a vertical stretch. A vertical shrink is going to push that graph down towards the x-axis. So it's actually going to flatten it. when you look at it visually. All right, so when we talk about transformations of absolute value functions, we're looking at the same thing that we did before, the same equation, which was a absolute value of x minus h plus k. We talked a lot about h and k yesterday, but today we're going to focus on a and what a will do to our graph, how it changes our graph. So as a review, h is the horizontal shift. If it's a plus, it's going to shift it to the left. If it's a minus, it's going to shift it to the right. K is the vertical shift. If it's a plus, it shifts it up. If it's a minus, it shifts it down. And then your vertex again is h comma k, where h is the opposite. So remember, h has to be the opposite sign. So if it was a negative, when you put it in the vertex, it's going to change to a positive. If it's a positive, when you put it in the vertex, it's going to change to a negative. All right, now let's focus on a. So a is the number in front of the absolute value. So up until now, you haven't seen an a value. So you might have thought, oh, there was no a value. Actually, the a value for all of the examples we saw yesterday was 1. So if you don't see an a value, you know there's an invisible 1, so your a is 1. If a is positive, then your graph is going to be facing up, so it's going to be a V-shaped graph. If your a is negative, that's a reflection. So when your a is negative, it's a reflection in the x-axis, and it's going to flip your graph upside down, so it's going to be facing down this time. So 3 things that a value will tell us. It will tell you if there's a reflection. So if it's a negative, it's going to be a reflection. The second thing it could tell you is if there's a vertical stretch or a vertical shrink. So if a is 1, then you don't have to worry about it. It's not a stretch, it's not a shrink. But if the absolute value is greater than 1, it's going to represent a vertical stretch. And if the absolute value is between 0 and 1, it's going to represent a shrink. So what does that absolute value part mean? It means basically whatever your a value is, make sure it's positive first, and then see, is that number bigger than 1? If so, it's a vertical stretch. If that number is less than 1, it's a vertical shrink. So whatever your a value is, change it to a positive. If it's already a positive, you don't have to do anything. And then look at that number and see, is it bigger than 1? Because that's going to stretch your graph. If it's less than 1, it's going to shrink your graph. And if it's 1, there's no stretch, there's no shrink. Questions? All right, let's go ahead and get into some examples. So example 1, graph the following function, f of x equals negative absolute value of x. So that looks very similar to our parent function, which is just the absolute value of x. The only thing that changed here is that there's now a negative in front. So let's go ahead and do our classic table of values. So I'm going to use the following x values, -2, -1, 0, 1, and 2. And then to get the y values, you're going to plug in the x into your function. So let's start with -2. If I plug in a -2 for x, I'm going to take the absolute value of -2, which is +2, and then I have this extra negative outside of the absolute value. So my +2 is going to turn into a -2. So again, plug in the -2. So the absolute value of -2 is +2, but then you have this extra negative that's going to change this back to a -2. Now we're going to do -1. So the absolute value of -1 is +1, but you still have that extra negative. So now it's going to be -1. Then we've got 0, plug in a 0. So absolute value of 0 is just 0. No such thing as a -0. So it's just 0. Now we're going to plug in a 1. So absolute value of 1 is 1, but you still have that negative in front, so it's going to be -1 now. And lastly, 2, plug in a 2. So absolute value of 2 is 2, and then put that negative in front, so it's going to be -2. Any questions about how we filled out our table of values? All right, let's go ahead and graph then. So we've got -2, -2, -1, -1, 0, 0, 1, -1, and 2, -2 as our points. If you have a straight edge available, go ahead and grab that straight edge and connect your points together to make a George's V. Look at that, so beautiful. I love graphs. Okay, just for funsies, let's go ahead and compare this to our original parent graph. So I'm going to do this in black. Remember, our original parent graph has a vertex of 0, 0, and it goes up 1 over 1 on the right and up 1 over 1 on the left. So you'll notice that the green graph is very similar to the black graph except for one difference. So green graph is pretty similar to the black graph except for one difference. So let's go ahead and talk about that in our questions over here. So first question, describe the transformation. So I'm going to go ahead and call on someone. Tell me what happened to the graph. It doesn't need to be super mathematical. Just tell me what difference you see. How did I go from the black graph to the green graph? How did I go from the black graph to the green graph? What do you think, Lexi?
Was there like a reflection over the x-axis?
Oh my gosh, beautiful, yes. So you even used the correct mathematical terms for that. So yes, so it basically flipped over the x-axis, and the fancy mathematical way we say that is there was a reflection in the x-axis. Great, good job. All right, next question. What's my vertex? What's my vertex for this green graph? Conrad.
Is it 0, 0?
Beautiful, yep, 0, 0. You guys are just on it today, good work. All right, so just like yesterday, you might be wondering, do I need to create a table of values and plug in all these x values to get my y values just to graph an absolute value function? No, you do not. So there is a shortcut. You don't have to use a table of values to graph. What you do need to do, some of them are very similar to the steps we did yesterday with just a couple things added in. So first step, you want to identify your h, k, and your a value. So that part is new. You also want to identify your a value. Step 2, plot your vertex just like yesterday. Step 3, use the a value to determine your slope and plot 4 other points. So yesterday, your a value was always 1, which is why we always went up 1 over 1. But today, your a value could be something other than 1. So you want to make sure you look at that a value to determine your slope because it won't always be up 1 over 1. And lastly, step 4, connect the points. So we did example 1 using a table of values, but we could have done it using these steps as well. I would first identify my A, my H, and my K. You'll notice that I don't have an H because the X is all by itself in the absolute value, so that would make my H 0. You'll notice I don't have a K because there's nothing behind the absolute value, so my K is also 0. And then my A, there's a negative in front of the absolute value. So I know my A is negative, but there's no number. If you don't see a number, you can assume it's going to be a 1. So your A is -1. You'll notice that the A value does not change the vertex. So when Conrad said the vertex was 0, 0, it's still dependent on your H and K. The A value does not affect the vertex at all. It's still H comma K.
Can you explain why it's -1 again?
Can I explain what? Sorry, Tyler.
Why it's -1 again?
Yeah, so A is always the number in front of the absolute value. So do you see how there's a negative in front of the absolute value? So that's where the negative came from. But do you see how there's no actual number in front of the absolute value? Because there's no number, we just assume the number is 1. Any other questions? Okay. And then,
A is absolute value.
what'd you say?
So the A is the absolute value.
A doesn't stand for absolute value. A stands for the vertical stretch, shrink, or reflection.
Okay.
Different variable, just like H and K. Good question. Any other questions? Okay. And the reason, so once you've got that, the A is going to tell you your slope. So once you plot your vertex, which is at 0, 0, your slope is -1. And remember from Algebra 1, your slope is rise over run. This isn't a fraction, but we can change it to a fraction by putting it over 1. So this is telling you that from your vertex, you have to go down 1 over 1, down 1 over 1 on the right side and the left side to get your V. And we'll do a couple of examples like that as well. But just so you know, you don't have to do the table values every single time you try to graph absolute value. Any questions on this before we go to the back? All right, let's go ahead and go to the back then. So example 2, graph the following function, f of x equals 1/4 absolute value of x minus 3 plus 2. We want to describe the transformation, find the vertex, and then graph. So the first step is you want to identify your A, your H, and your K. Your A, your H, and your K. All right, I'm going to go ahead and call on people to help me do this. What's my A, what's my H, and what's my K? Nick.
You want me to say all of them?
Yes.
Your A is 1/4. Your H is -3, and your K is 2.
Perfect. Okay, so we haven't talked about what the A value means to our graph. So the first thing you want to check is whether your A is positive or negative. So right now my A is positive, which means I don't have a reflection. It's going to be facing upwards, so it's going to be a V shape. The second thing you want to do is once you figure out if it's a positive or negative, you want to check and see is there a stretch or if there's a shrink. If your A value is 1, you don't have a stretch, you don't have a shrink, so you don't need to worry about it. But right now, our A value is 1/4. First step, make sure it's positive. So 1/4 is already positive, so you're good to go. And then check and see, is this number 1/4, is it less than 1 or is it greater than 1? 1/4 is less than 1, which means that this is going to be a vertical shrink. So anytime it's less than 1, it's a shrink, and it shrinks by 1/4. So that's the new part we're learning today. So again, first check if it's positive or negative. Positive means that it's facing upwards. Negative means that it's a reflection. Second, change that number to a positive and see if that number is less than 1 or greater than 1. If it's less than 1, it's a shrink. If it's greater than 1, it is a stretch. Okay, I'm going to call on someone for the next question. How is my graph going to transform based on the H and K? How are my H and K going to affect my graph? What do you think, Christian?
It's gonna go right 3 up 2.
Right 3 up 2. And what's my vertex going to be, Jaden?
I don't know.
So remember, your vertex is always H comma K, where H is the opposite. So what's your H value?
It'll be 3, 3, 2.
2, exactly, because you want to change that -3 to a +3. All right, let's go ahead and graph that. So start by graphing your vertex. So that's at 3, 2. And then remember, you want to look at the A value to get the slope. So slope is always rise over run. So this is saying you're going up 1 over 4. So to get my next points on the right side, I'm going to go up 1 over 1, 2, 3, 4. And that's my second point. And then I'm going to go up 1 over 4 again. It's going to go slightly off the graph. That's fine. Just kind of guesstimate it. So you got your right side, but you still need to fill out the left side. So you're going to go up 1 over 4 again, up 1 over 4 again on the left side. And then go ahead and take your straight edge and connect the points together. And you'll notice that it's a super flat V. Oh, yeah, that did not look good. Just for fun, let's go ahead and compare it to our original parent graph. So remember, our parent graph starts at 0, 0. That's our vertex. And the A value is 1, so it just goes up 1 over 1. And you'll notice that compared to the black graph, my green graph is flatter. That's because I took the ends and I shifted them down, pushed them down towards the x-axis because that's a shrink. And it moved to the right 3 up 2. Any questions on example 2?
I got a question.
Yeah.
So for the parent function, how did you get, do you always do like up 1 over 1?
Yeah, so if you remember from yesterday, our parent function always has a vertex of 0, 0, and it always goes up 1 over 1.
Okay, thank you.
All right, example 3, graph the following function, two absolute value of x plus 3 plus 1. Graph the describe the transformation, find the vertex, and then graph. So first step, you want to identify your A, your H, and your K. Your A, your H, and your K. Go ahead and give me my A, my H, and my K. Tyler.
Your A would be 2.
Mm-hmm.
Your H would be, I didn't write that one down. I gotta wait. Your H would be 3, and your K would be 1.
Yep. A is 2, H is 3, K is 1. All right, next part, we got to describe the transformation. So let's look at the A first because we haven't done A's before. First step, check and see if it's a positive or if it's a negative. Since it's a positive, there's no reflection, so you're good to go for that. Second, since A is not 1, you know there's going to be a stretch or a shrink. If A was 1, then you don't have to worry about it, but since it's 2, you know there's going to be a stretch or a shrink. First, you're going to change this to a positive if it's not already a positive. So 2 is already positive, so you're good. And then check and see, is this number bigger than 1 or less than 1? So since 2 is bigger than 1, this is going to be a vertical stretch. So anytime your A value, once you change it to a positive number, is bigger than 1, it's going to be a vertical stretch, in this case by 2. Questions on that? All right, and then go ahead and describe the transformation for the H and the K. Natalie. Natalie, could you describe the transformation for the H and the K?
Sorry, my mute button wasn't working.
That's totally fine.
From the H to the K.
Or how does the H and the K, how does it transform my graph?
Oh, okay. Wouldn't it be left 3 and up 1?
Yep. left 3, up 1. Good job. And then what's my vertex going to be? What's my vertex going to be? Noah.
Left 3, 1.
You said 3, 1?
Yeah.
Almost, just don't forget that your H value has to be the opposite, so just change that 3 to a negative.
-3.
All right, go ahead and graph your vertex. So it's going to be at -3, +1. That's your vertex. And then you're going to use your A value to get the rest of the points. So right now your A value is 2. You want to change that to a fraction. So you can always change a fraction by putting it over 1. So you can change that to 2 over 1. So that means from your vertex, you're going to go on the right side up 2 over 1, up 2 over 1. And then you're going to get the left side. So on the left side, you're going to go up 2 over 1, up 2 over 1. All right, so then you're going to go ahead and connect these points together. And oh my gosh, look at this beautiful absolute value graph. Is there anything better than that? No, there really isn't.
Wait, I have a question.
Yeah, what's up, Gavin?
Why is it left 3 instead of right 3 since it's positive?
Great question. Remember, H is always a little tricky. It's the opposite of what we think. Anytime it's a plus for your H, you're going to go to the left, and anytime it's a minus, you're going to go to the right. I think it was in this class yesterday. The reason why is because if you look at your original formula, you see how there's a minus sign in front of the H? That's math way of saying opposite, so that's why we have to take the opposite, whereas the K, you'll notice there's a plus sign in front, so that's why the K just stays the same.
Oh, okay.
Great question, though. All right, let's go ahead and compare this to the parent graph. So again, the parent graph always starts at 0, 0, and it goes up 1 over 1, up 1 over 1. And then we connect the points together.
I got a question about the vertical stretch.
Yeah, what's up?
So how do we get it? Like, is it always going to be A?
It's always going to be A, yep.
So like, you know how A was 2?
Mm-hmm.
So that'd just be the vertical stretch?
Yeah, so you know it's a stretch if that A value is bigger than 1.
Okay.
And if it's less than 1, like in example 2, it's going to be a shrink.
And then after we plot the vertex, we just go like up 2 over 1 on the graph?
Yep.
All right.
Great question. Any other questions? All right, let's go to example 4. You'll realize this about me. I'm notorious for making typos. So just change that more. My resolution this year to be better about making typos. All right, graph the following function. F of x is equal to negative x plus 5, or negative absolute value of x plus 5 plus 2. First step, identify your A, your H, and your K. All right, go ahead and give me my A, my H, and my K. Jordan.
The A would be 1.
Awesome, but also remember you have a negative in front of that.
H would be 5. And K would be 2.
Awesome. So I really like, Jordan, how you realize that just because if there is no number, it has to be a 1. So there is no number in front of the absolute value, but you recognize that if there is no number, the number is 1. And it's a negative 1 because there's that negative symbol in front of the x plus 5. So good. That's a tricky one. A lot of students forget that A is 1 if there is no number in front of the absolute value. All right, describe the transformation. So let's start with the A first. So when you look at the A, first check, is it a positive or negative? Since it's a negative one, that means we're going to have a reflection in the x-axis. So if your A is negative, you're going to have a reflection in the x-axis. Now we're going to have a stretch or a shrink. So to check if you have a stretch or a shrink, change the A to a positive if it's not already positive. So we're going to change that -1 to a +1. And if it's 1, then there is no stretch and there is no shrink. If it's just 1, there's no stretch, there's no shrink. Any questions about that? All right, now go ahead and describe the translation based on the H and K. So how is my graph going to move based on that H and K? What do you think, Clervin?
Left 5 up 2.
Perfect. Left 5 up 2. Beautiful. All right, go ahead and give me my vertex. Go ahead and give me my vertex. Bow.
Five, 4,
5, what'd you say, sorry?
5, 4, 22, -2.
Yep, the only thing I'm going to say is that remember the H has to be opposite, so it has to be -5 too. Good. All right, let's go ahead and graph that. So you've got your vertex at -5, 1, 2, 3, 4, 5, up 2. Then we're going to graph our points based on the A value. So it's -1, it's a whole number, but we can change it to a fraction by putting it over 1. So -1 over 1. Then that means that you're going down 1 over 1 because it's a negative. So you go down 1 over 1 on the right side, down 1 over 1 on the left, or sorry, on the right side again. Then go to the left side, down 1 over 1, down 1 over 1.
How come the 5 is negative?
Because remember when you write your vertex, you always want to do the opposite of the H value. So since it was +5, when you put it in the vertex, you got to change it to a -5.
Okay.
Yeah. But that's only for the H value, not the K value. All right, go ahead and connect your points together. So you'll have your upside down V. And then you can compare it to the absolute value parent function, which starts at 0, 0. That's your vertex. And it goes up 1 over 1, up 1 over 1. And you'll notice that we had a reflection. We flipped our graph and we shifted it left 5, up 2. Questions on example 4? All right, the last one, example 5, write an equation for the parent function f of x equals absolute value of x that has been translated 7 units to the right and 4 units down. So this time we're working backwards. We're given the transformation and we have to figure out the equation. So same thing we did yesterday, except we're going to add an a value. So write out your a, your h, and your k. If I'm going 7 units to the right, I know right means minus, and it's going to be an h value because we're going left and right, horizontal shift, so -7. And I'm going 4 units down, so that's a k value. Down means negative, so -4. And it doesn't say anything about a reflection, so I know my a value is going to be positive. And it doesn't say anything about a stretch or shrink, so I know it's going to be a positive 1. Remember, when you write your equation, you want to choose a different variable besides f, so I'm going to go with g. So g of x is equal to a, which is 1, absolute value of x minus 7, because your h value has to go inside the absolute value, minus 4. Your k value goes at the end. Conventionally, we don't include that 1 in front, so I'm just going to simplify it and clean it up a little bit, get rid of that 1 in the front, and it's just absolute value of x minus 7 minus 4. Any questions about example 5? Okay, let's go over your homework for tonight then, if there are no questions. And then we didn't have time to do Kahoot today, but that's fine. We'll do it tomorrow. Your homework tonight is going to be on Big Ideas Math. So you should still have the homework from yesterday available because that's not due till tonight. And then you should also have a new assignment available that was given to you today. So if you log into Big Ideas Math and then you click assignments, you should have 2 assignments available. This top one is the one that's due today, August 5th at 11:59. The second one is August 6th. They're both labeled 1.1 because there's a part 1 and a part 2. Just look at the due dates to know which one is due today. That's the one at the top. And then the second one is the one that's due tomorrow, 11:59 p.m. Any questions about homework for what's due today? Don't forget to hit submit. That's the biggest mistake I see. So even if you finished it, but you didn't if you didn't remember to hit submit, then I don't see that you turned it in on time. So really make sure you hit that final submit button when you're done. Just as a reminder to get ready for tomorrow, print out your notes. They'll be uploaded on Canvas today by 8 p.m. And then do your Big Ideas assignments. The first part is due tonight. The second part is due tomorrow. All right, you all are free to go if you have no questions. I'll stick around for a few minutes after the period if you do have any questions. But other than that, see you tomorrow. Have a great one.
On Big Ideas Math, it doesn't show us having an assignment.
It does not. Oh, geez.
It says parent, all that's available is parent functions and transformations.
Did you already submit one?
I submitted yesterday's.
Okay, so if you already submitted it, it won't show up. So the one that you see today is the one that I assigned for today. Ida, did you have a question? Because you're still muted.
My bad. I didn't know it was. Okay, so I have a question about the vertical stretch and the shrink. Like, I'm confused on those two because how do you know if it's like a shrink or a stretch? Because I'm still like kind of iffy about that one.
Okay, so once you find your A value, right, you're going to change it to a positive no matter what. And then,
why would you change the A value to a positive?
Because the positive and negative only tells you if it's a reflection or not a reflection. That's what the positive and negative tells you. But you don't care about the positive and negative when you're talking about a stretch or a shrink. You have to separate the two. So then once you change it to a positive, if it's a 1, there's no stretch, there's no shrink. You don't have to worry about it if it's just a 1. You do have to worry about it if it's not 1. So then to see if it's a stretch or shrink, you're going to ask yourself, is the number bigger than 1 or is it less than 1? If the number is bigger than 1, it's a stretch. If it's less than 1, it's a shrink.
So bigger than 1 is a stretch, less than 1 is a shrink.
And if it's just 1, then don't worry about it.
Okay, and then I have a question about the reflection part.
Mm-hmm.
I'm a little bit like, confused on that one. Everything else I get, like how to find the H and the K value, how to graph it. I just need a little bit help on the reflection. Like, could you go like more into detail?
Yeah, so reflection, all you have to remember is, or all you have to ask yourself is whether A is negative. If A is negative, it's going to be a reflection. If A is positive, it's going to be regular.
All right, thank you.
So if A is not 1, what does...
If A is not 1, then you have to figure out if it's a stretch or a shrink. So change A to a positive if it's not already positive.
So it's 3.
So is that bigger
So
than 1 or less than 1?
what?
So is 3 bigger than 1 or is it less than 1?
Bigger.
Bigger. So bigger is stretch.
And so it like stretches out by 3?
Stretches out by 3. Should stretch up by 3.
Up by 3. Okay.
It's a vertical stretch.
Okay. Thanks.
Mhm.